we have here a sector of a circle. We have the part ABC that form a triangle, and then the shaded area that represents a segment of the circle. The figure shows a sector of a circle. The angle BAC is 60 degrees, and we have the 7 representing the radius of that circle. We need to calculate the area of a triangle ABC. Alright. Now, in calculating the area of a triangle, part A, we can use the formula that says the area of a triangle is half this side, one side, that is AB, times the other side. Let me write the B properly here, times the other side AC, times the sine of the angle between them, sine 60. Alright, so it is half by 7 times, this would have to be 7 cm2, it's the radius of the same circle, times 7 times the sine of 60. What's the sine of 60? Now that's going to be 0.866. Let me use my calculator here, put it in advanced mode, and it's showing in degrees. So I say sine 60 is equal to 0.866. So we have times 0.866. So this is 7 7 49, half of 49, so it is 49 over 2 times 0.866. So we calculate that. So 49 divided by 2 multiplied by that. To be sure, I'm going to put the 49 over 2 in brackets to make sure that no mistake is made, equals 21 point, call it 0.22, use 2 decimal places, 21.22 centimeters squared. That's 21.22 cm squared. It is for the sector of the circle. Alright, now we're going to calculate also the area of the shaded region. Now remember, if you had the whole circle, say this was the whole circle with radius 7 centimeters, the area of the circle would be pi times radius square, pi r squared, which would be pi, let's use 3.142 for pi for now, 3.142 times 7 squared. However, it is part of a circle. What we have is a 60 degree angle here. We want to calculate the angle of the whole thing, and then we remove the angle of the triangle and we will get the angle of the shaded region. So let's calculate the angle of the entire thing. The area of the sector, this now would be for the whole circle, but the area of the sector is what fraction of the sector does it take up, or what fraction of the whole circle does the sector take up. We're going to see it would be for the whole circle pi r squared multiplied by the angle in the sector divided by the total angle of 360 degrees. That's what it would be. So it's 3.142 times r squared, which is 7 squared, times 60 over 360. Alright, so what you have now is 3.142. We're running out of space, you know. let me continue up here. The area of the sector is going to be 3.142 times 7 squared is 49 times 60 divided by 360 is 1/6. Is 1/6. So it's like all of this over 6. 3.142 times 49 all over 6 when you calculate it. So let's do that. 3.142 by 49 over 6. So it's 3.142 times 49 equal, and then divided by 6 equal, you have 25.66. So the area of the whole sector is 25.66 centimeter squared. Alright, let's rub out some of these things. Let's erase because we need a space. Before we erase, let's write the area of the triangle up here first. The area of the triangle was 21.22. Alright, so the area of the sector is 25.66. Let's just remove some of this working here. Alright, now what we consider now is that for the whole sector it is 25.66 for the entire sector, for everything. Then for the triangle alone, not the shaded region, no, this triangle alone is 21.27. So to find the shaded area, we remove a triangle from the whole sector and we have just a shaded area left, so we subtract. So 6 minus 7 you can't, is 5, 16, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, so we have 9. Alright, so 16 minus 7 is 9, 5 minus 2 is 3, 5 minus 1 is 4, so 2 minus 2 is 0. So the shaded area is 4.39 centimeters squared. So the shaded area is 4.39 centimeters squared. You see that? After that, now the length of the arc. What we're talking about, so the length of the arc would be the length of all of this part here. If you should use a tape measure and measure that, what would you get as the length? Now again, we look at the whole circle. Let's just erase this what we have over here. Right, what you do later on, you can come back to this exact point in the video, or you can do a screenshot, or better yet write it down in a notebook. So we have 4.39 written over here already, so we can erase this. We know the first two answers. Now what about the length of the arc? If we again consider that we have a whole circle, the arc, if we come from here to here with the same sector again, the arc that we're talking about would be about this part here, the curve. So the arc would be this curved part here. Now the question is, what length is that? Remember now that the arc is part of the circumference. What would be the length of the entire circumference? Remember, the circumference is 2 times pi times r. Now the arc, the length of the arc will be part of it, would be the whole circumference, but then you cut it down into the fraction that it takes up of the entire circumference. So you multiply by the angle in here, 60 degrees, over the total angle of 360 degrees. So it takes up that proportion of the entire circle. So the arc length, let me write that again. The arc length is 2 times 3.142 times radius 7 times 60 over 360. Again, we know that it is 1/6. So let's multiply the 2 by 7. 2 7 14, so it's 14 times 3.142 times 1/6, which is the same as time divided by 6. Alright, so 14 by 3.142 over 6, let's see what that is. 14 times let's do that again. 14 times pi. You have the entire pi on a calculator you can use instead of the 3.142. Let me just check, make sure that it is alright. Pi, good. So it's going to be 14 times pi equal that divided by 6 equal 7.33. So the arc length is equal to 7.33 centimeters. So it's 7.33 centimeter. Remember, this was centimeter squared. This was centimeter squared areas, and then 7.33 centimeters for the arc length.